The design recipe in Racket may seem annoying at first, but trust me, it really helps with improving your debugging logic, and you'll definitely find that useful once you've gotten a bit more used to programming and moved on to languages which are more practical than Racket, to say the least. Um, anyway, today we'll be learning about the design recipe, and um, the design recipe in Racket mainly has five components: the purpose, the contract, examples, the definition, and tests. So the purpose is this line. The purpose basically specifies what the function is going to do. So I've written out a dummy function over here, which basically it's called sum of cubes, and it adds up the cubes of two numbers which you specify to it. So that's what the purpose tells you. The purpose says sum of cubes n1, n2 as the sum of cubes of two numbers. The contract tells what type of values it takes in and what type of values it gives out. So we know sum of cubes takes in two numbered values and outputs a number value. Then we write down an example. It is really important to do this example before we actually write down the function, because you're supposed to like figure out these examples by hand in your head, not through the code. This is because if you figure out an example by yourself, obviously in this case, a sum of cubes function is extremely simple and it does not seem clear in this case, but generally in complex code, you'd want to figure out an example by yourself by hand and then write the code for it, so that once you run your code and the test fails, you know something has gone wrong over there because you 100% know what you did by hand is correct. So you write down the example by hand and then you start writing your code, which I did over here, and then you write a test for it. So let's make another function, and I'll walk you through um, writing the design recipe for it. Okay, so let's make a function called, say, um, both even n1 n2, which would um, tells us if two numbers are both even. Actually, let's say returns two numbers are both even. The contract for this uh, would be we're taking in two number values and we're outputting a true or false. So that would mean a Boolean value. Um, an example for this can be check expect. So I'm not sure if you guys are familiar with check expect. So this function, it checks the output of one function against another thing you can predefine, or maybe have a second function do it for you. So it basically compares two of them, and yeah. So check expect both even 4, 6. This should return true, right? And check expect both even 4, 5 should return false. In this case, as you see, we have written two examples just because just this one isn't enough, because even if it returns true here, it's important this function returns false here as well, otherwise it's incomplete. So you want to test for all the cases you can think of, and then you want to write the function itself. So define both even n1, n2, and even n1, even n2. And then we can go on writing our tests. Check expect both even to 10 to true. Check expect both even -2, 8. This should also be true because -2 is also an even number. Check both even 0, 1 should be false. And we're going to try running our application over here. And all 7 tests passed.